Alright, this video is on how to write isotopic notation. A couple things we need to know is some basic atomic structure. We have three subatomic particles. Okay. Those three subatomic particles being protons, neutrons, and electrons. Now, protons, they are positively charged, and they are found in the nucleus. Your neutrons have no charge, and they are also found in the nucleus. And your electrons are negatively charged, and they are found outside of nucleus. Okay? So, it's important to note that we actually can call these two things a special name because they both are in the nucleus. We call them nucleons. Okay? Those nucleons, they're going to contribute to the mass of an atom. Okay? An atom is the smallest unit of matter. Okay? So the mass, or we'll probably call it the weight, okay, the mass or weight of the atom is based on the number of protons and the number of neutrons. The electrons, which are not nucleons, their main, I guess, attribute is they're going to tend to the volume of the electron, meaning, or of the atom, meaning how big it is, and then it's also going to add to or explain the reactivity of certain atoms is based on how many electrons they have, which we'll talk about when we start getting into chemical reactions later on. So, subatomic particles, protons, neutrons, electrons. Protons and neutrons together are known as nucleons, and then they contribute mainly to the mass of the atom. And then the electrons contribute to the volume. Electrons have no charge, and they are found outside the nucleus. Electrons have a negative charge, found outside the nucleus. Neutrons have no charge, found in the nucleus. Protons have a positive charge and found in the nucleus. Okay, from this information, we should be able to understand the concept of what an isotope is and how to draw isotopic notation. So we'll take a look at isotopes right now. So, an isotope an isotope is when you have two atoms, and there could be more than two, but just say two atoms of the same element. An element is gold or silver or mercury. Okay, if I was to take an atom of oxygen and I was to take two atoms of oxygen and say they have different masses, they have different weight, then we call those two atoms of that element isotopes. So two atoms of the same element with different weights or masses. Okay. Now, what's particular about this is the factor that is contributing to the weight, the difference in the weight between one atom and the next, is not the number of protons, but the number of neutrons. So this mainly means different number of neutrons. Okay, that's important. The reason why it's important is because if you change the number of neutrons, then that just changes the weight. That doesn't change the identity of the element. But if you change the number of protons, not only will it affect the weight, but it will also affect what element it is. Okay, so for example, if I had oxygen, oxygen has 8 protons. If I give another proton to oxygen, oxygen stops being oxygen and starts being fluorine. Okay, so I mean, you can't, that's if you add your protons, but we don't do that. We're not going to add protons, okay, because that changes what the element is. We don't want to change what the element is. We just want to look at different atoms of the same element that have different masses, okay? So let's take a look at carbon. We have carbon 12 and we have carbon 14. Both of these, okay, have 6 protons. And because they're neutral, meaning they don't have a charge, they also have 6 electrons. Okay, because they need to equal out. But what's going to be different is the number of neutrons. Oops, I don't want to put 0 there. Okay, it's going to be the number of neutrons. Now, this number is making reference to the atomic mass, but we'll call it weight, just to make things simple. The atomic weight, okay, and it's really equal to the number of protons plus the number of neutrons. Okay, so that should be an N. Number of protons plus the number of neutrons. That is the atomic weight. So if I wanted to find out how many neutrons were in carbon 12, I would take 12 and it would be equal to the number of protons, which would be 6 plus, in this case, X. So this would be X. What do? I would subtract 6, and X is going to equal 6. Right? Same thing down here. If I wanted to find out the number of neutrons in carbon 14, I would take 14 and I'd subtract 6. Okay? Or I rearranged it algebraically, but 14 minus 6 is going to equal 8. So what does that mean? That means the number of neutrons in carbon 14 is 8, and the number of neutrons in carbon 12 is 6. Now, if you notice, these two elements are still the same element. They're still carbon. Still carbon. The only difference is their atomic weight. That's the only thing different. And when you have two atoms of the same element that have different atomic weights, you call those isotopes. Okay? Now next, we'll talk about isotopic notation, which is how we write isotopes and how we can write them differently. So let's go ahead and stick with carbon. Or this is a general example. We have the symbol. The symbol can be found on the periodic table. I'm going to have the symbol be X because it's going to be a generic element. There is no X for an element symbol. So we have X. All right. Now here we have, in this case, A. And then we have Z here. You're thinking, well, what do those two letters mean? This letter right here means atomic weight, which you learned in the last slide that atomic weight is equal to protons plus neutrons. Okay? This guy down here, this is the atomic number. This is equal to just the number of the protons. Okay? So, from this information, we can get a wide variety of different things. We'll be able to find out the atomic weight, we'll be able to find out how many protons, how many neutrons, and we'll actually be able to find out how many electrons. And the reason how we can find electrons is, we'll talk about here, in a second, but there's nothing right here. Okay, there's no number, there's no negative number, positive number. Usually if a substance or if an element has a charge, which means it's no longer an atom, it is now an ion, then you're going to have the charge written in that blue circle. Okay, whether it be positive, 3 positive, 2 positive, 4 positive, or -1, -2, -3. Okay, if we have that, if there's a number in there, then that's going to tell us that there is a difference between the numbers of protons and the number of electrons. But for the first couple examples, we're just going to do just the symbol of an atom and assuming that the number of protons and electrons are equal. Okay, so let's go ahead and drop that. And let's do carbon 12. Okay, carbon 12, it's isotopic notation. This is what isotopic notation is. I take the symbol. In this case, the symbol for carbon is C. And then I put the atomic weight up in the upper left-hand corner. In this case, the atomic mass is 12. The number of protons for carbon doesn't change. I'll usually give you this reference so you don't have to use a periodic table. It would be 6. Okay, and if you have this information, and there's no charge, so there's nothing written right here, right? It's blank, so that means there's no charge there. Okay, so I will go ahead and erase that. I don't want to confuse you guys. Okay, now from this information, this is your isotopic notation. Okay, isotopic notation. This is, if I ask you to write isotopic notation, this is what I want. Okay, it's symbol, atomic weight, and an atomic number. Okay, that's what I want, which is exactly what we have here. From this, I can tell the number of protons, the number of neutrons, and the number of electrons just based on this. Okay, so the number of protons is always the same. It's this guy right here, Z. Atomic number, in this case, it's 6. Because there's no charge, meaning it's a neutral atom, there's no, in the upper right-hand corner of the symbol, there's no number there, then that means the number of protons and the number of electrons are equal. Now, to get the number of neutrons, it's really simple. Okay? The number of neutrons is, so number of neutrons, remember, is equal to A minus Z. In this case, if this is A and this is Z, all I would do is subtract 6 from 12 and I'd get 6, which is the number of neutrons. Okay. If I was to change my isotope, say to carbon 14, which is what I'll do next, I draw my symbol. 14 goes up here. 6 still goes there because it's still carbon. If it wasn't carbon, then it wouldn't be 6. And then, of course, there's still no charge there. So from that, I can get protons, neutrons, and electrons. And see what kind of answers we get here from that. All right? So first, electrons and protons are going to be equal because there is a neutral charge. So 6 and 6. But I take 14 minus 6, and I get 8, which means, because this is, remember, this is A, and this is Z. So A minus Z. A minus Z equals number of neutrons. All right, 8. So I will show you a chart that I want you to do. It'll probably be online. It'll be under Isotopic Notation Worksheet. Okay, and what I want you to do is I would like you to fill in that chart. Things you'll be able to, or things you will be asked to do, will be things like identify the atomic mass or the atomic weight, identify the atomic number, and the number of protons, neutrons, and electrons. Now, before you can do that, there's going to be some ions in there. Ions are charged particles. So let's go ahead and take a look at one of those before you get going on that. Chlorine has a certain number of electrons that's going to want it to gain electrons. So if we just look at the atom, the protons, neutrons, and electrons, okay, 35 and 17. Okay, the protons, neutrons, and electrons. This would be So the number of protons is 17. Now the number of electrons is also 17 because this is the atom. Okay, and then the number of neutrons is 18. Okay, because 17 plus 18 will be 35. Yeah, okay, 17 plus 18 is 35. So, what are these ions I'm talking about? Well, sometimes one of the electrons is either gained or lost because of the reactivity of it. In this case, chlorine is going to want to gain an electron, so it looks like this, and it has a negative charge there. So when you see a negative or a positive with no number, that means 1, negative 1 in this case, or positive 1 in another case. Okay, so 35 and 17. This is what the isotopic notation looks like for an ion. Okay, it has a charge there versus just having the numbers to the left. Okay, and if I was to identify the number of protons, neutrons, and electrons here, okay, this would still be 17, this would still be 18. Now the question is, how many electrons do I have? And the answer is going to lie with, if I had 17 when I was neutral, and it gained an electron, meaning it has a negative charge now, that means it has one more electron, because electrons are negative, one more electron than it has protons. So if I want to determine how many electrons this chloride ion has, it's going to be 17 plus 1. So it'll have 18. Okay? So I'll go ahead and do an example of where an atom loses electrons versus gaining right now. Okay, so let's take a look at sodium. Sodium 2311. Sodium is one of those atoms that likes to, or one of those elements that likes to lose electrons. It's much rather lose electrons than gain them. So the regular old atom has protons, neutrons, and electrons. And those protons are going to be 11, the electrons are going to be 11, and the neutrons are going to be 12. Okay? But like I said, in this case, sodium turns into the sodium ion and is plus, which means it's plus 1. Now, even though it looks like you think plus is an additive thing, what's happening is it's losing a negative charge. Because what it ends up meaning is there is one more positive charge, meaning one more proton, than there are electrons. Okay, so this doesn't change. This is still the same. Okay, but protons, I'm still going to be 11, right? Because if I don't have any, if I have something other than 11, then it stops being sodium. Okay, my neutrons, I haven't changed my mass yet. Okay, so I didn't change my mass, so that's still 12. But my electrons, like I said, I'm going to end up having one more positive charge than I will negative. So what that means is I must have one fewer electron, which means I have 10 electrons. Okay? So, and then, like I said, this right here is how you would write the isotopic notation for an ion. It's a positive charge, and then you saw the chlorine earlier. Okay? So, I'll go ahead and put the post up for or the worksheet. Remember, it's titled Isotopic Notation Worksheet. And then you should be able to complete the selected columns that I put on there. Don't do all of them, just do some of them. Okay? Actually, you know what? Let's see if I can bring it up right now. Alright, so actually, hey, here it is. So I'll still put it up online so it's a separate file, but it's best if you actually pay attention to this because I don't want you to do all of these, I only want you to do some of them. Okay, I want you to do these two right here. Okay, and let's see, these two right. Okay, so we'll do this one right here, and we'll do one more. What about this one? Okay, if you were in class, then we did something a little different, but just do those four. Okay, I want the atomic number. I want the number of protons. I want the number of neutrons, the number of electrons. Okay, I'm going to erase it because I'm going to move it. Okay, and lastly, I want the mass number. Okay, and like I said, it'll be up on the table or up on the website so you can just fill in the table if you wanted to. Okay, if you have any questions, write a comment below or ask me in class.